Hello friends, today I'm going to solve LeetCode problem number 931 minimum falling path sum. In this problem we are given an n by n array of integers and we need to return the minimum sum of the falling path. Now what's a falling path? A falling path is for a given row the falling path lies such that it lies in the next row and the column is either -1 or the same the column or column plus 1. So basically let's see what it is. So for we start from the first row, so the falling path for any value in this row will lie in the next row. So the falling path will lie in the next row, and to find the column, suppose we are looking for this for the falling path of 1, then it would be either to the left, to just below, or to the right. So these three, one of these three could be, these three are the falling path, but we need the minimum one. So among these three the minimum is 4, so we pick 4. Now for the falling path of 4 we could either choose this value 8 here or 9 here. Since 8 is the minimum, we choose 8 here. So our answer here becomes 8 plus 4 plus 1, which is equals to 30. Now what if in case we had a value 2 here? In that case this would not be our minimum path, because our minimum path here, as you could see, will be 1 plus 5 plus 2. So it will be in this direction here, 1 plus 5 plus 2. So this means that just finding the to find the minimum path, it's not enough, it's not sufficient for us to just find the minimum in each row and then add them, because well, from 1, if we find the minimum in the next row, which is equals to 4, and also the minimum should fall in the falling path of the 1, since between 6 5 and 4 4 is the minimum. Now from 4 we could not choose 2 to as the minimum, even though like 2 is the 2 is the least value there, because it doesn't fall in the falling path. So we need to find the minimum for each of the values. So for each of these we need to find the minimum falling path, and then similarly for these also we need to find the minimum for each of for minimum falling path, and then finally return our answer. Now let's see how we could solve this problem. So to solve the problem we start from the very first row, and not actually we don't start from the first row, we start from the last row. And since we are in the last row, so the path, the sum, there is no falling path to for 7, right? Because there is no because it lies in the boundary. So the minimum sum for this row would be the value itself. Then what we do is next we move on to this row, one above. So for 6 the minimum path would be, we could move direct below or diagonally right. So diagonally right and direct below, and what we do is we take the minimum of these two values. So what's the most minimum value? 7 is the minimum, right? So 7 will 7 plus 6 would be equals to 13. So that becomes the minimum for this path here. So 13 becomes the minimum. For 5 we can go diagonally to the left, or just below it, or diagonally to the right. So among these three, which is the minimum? Of course 7 is the minimum, so we return the value 7 and we add it to the 5, and the value, the minimum value becomes here equals to, for this, the falling minimum falling path value is equals to 7 plus 5, which is equals to 12. So this value here becomes equals to 12. Now we need to find the minimum sum for this row as well, for this cell as well. So for this one we can move either to the left or to just below it, and among these two 8 is the minimum so far. So 8 plus 4 is equals to 12 again. So the value here becomes equals to 12. Now what we do is we move on to the next row and we start from the first cell. So for 2 we could go either this direction or in this direction. Among these two, this is the smallest one, so we add 12 to 2 and the value here becomes equals to 14. Now again, we move on to the next cell. For this one we can move in this direction or this direction or in this direction. Among these three again, which is the minimum one? Well, 12 is the minimum, so 12 plus 1 is equals to 13. So the value here is equals to 13. Now again, for 3 12 we could go in this direction, and both of them have the value 12, right? So we return 12 and 12 plus 3 is equals to 15. So we have done the calculation so far, and now I will return the results. The result will be equals to the minimum of the first row, and the minimum value here is 13, so we'll return our value 13 here. So I guess that is the minimum value. Yes, so output is equals to 13 for this example. So that is how we'll be solving this problem. We could solve this problem in two ways, iteratively or recursively. So we could solve this problem in these two ways. And also one thing is that, let's see here. Now when we are moving through these rows, so for finding the value of 2 for this cell, we need to move in this direction and this direction as well, right? For calculating value for this cell, we move in this direction, we move in this direction as well, and in this direction. So basically we are reaching this point more than one time. So we are reaching this cell, the value for this cell, more than one time, right? So it would be very efficient if we saved this in memory, if we saved the value for this one in the memory, so that we would avoid the recalculation over and over again. So that is why we will be performing memoization as well in this problem. Now let's dive into the coding. So I'll be doing the iterative solution because that is much more easier to understand. So let's create our n equals to that length, and then let dp equals to array of length n, and then for let I equals to 0, I is less than dp dot length. Well, basically dp is of length n, so we can use n here, and then I plus plus dp equals to, so what I'm gonna do is I'm just gonna copy our matrix, the value of matrix, to our dp, and now what I'm gonna do is iterative solutions. I'm gonna start my iteration from, since as you can see here, since our last row remains the same, there is no change there, so we'll start from the second last row. So the second last row is n minus 2 I should be greater than equals to 0, I minus minus, and then for let j equals to 0, so we start from the first column and j is less than n, j plus plus. Now what we do is we find the value for our dpij plus equals to what we find the value directly below our cell, so that would be equals to find directly below. We what we do here is for this one, for 5 directly below we add 8 to 5, right? So that is what we are going to do. dp plus dp I plus 1 and j, so that is directly below. And now to find the one towards the left, we need to check if the left value exists or not, because it would be the case where we are finding for the left one for 6, but there is no such value, right? It's out of our boundary, so we need to check if left exists or not. So if j is greater than 0, that is when we could go to the left. So if j is less than 0, then what are we gonna do is we need the minimum. So dpij is equals to math that minimum of the current value, or dp, or what are we gonna do is matrix I j plus the dp of I plus 1 j minus 1. And similarly we are gonna do it for n minus 1. So j should be less than n minus 1, only then we could go to the right, because j plus 1, if you do j plus 1 when j is equals to n minus 1, then the value of j will be equals to n, and n is lies on the border value, so j should be less than n minus 1. Now this will give us the minimum value of dpij, that is the minimum value at that cell. Now we also need the minimum value for that row, so minimum for that row, because at the end we need to find the minimum in that row, right? So for that case, what I'm gonna do is I'm just gonna min sum infinity and then infinity, and finally min sum equals to the minimum of dpi. Okay, but j here will be undefined, so yeah, so this will come inside here. So for each row we start from min sum equals to infinity, and what we do is we find the minimum value for that cell, and then we check is it less than the min sum. If less, then min sum will be the value of dp. If not, min sum will remain the same. So for each row we will be able to find the min sum, and then finally we are going to return our minimum sum here. Now let's run our code and see if it works or not. Okay, it's not working for our final test case, which only has one row and one column. So what we need a base case, base condition, right? Base condition, if min sum is infinity, that is when we return the 0th element, the first cell. Okay, it's still infinity. How do we check that? So if min sum, okay, so we return the minimum. No, we are not going to return the minimum of both of these two. Min sum is greater than or equals to infinity. I guess this will work. Oh no, this doesn't work. So yeah, I can do the length is greater than 1, then we return a min sum, else we return the element 0 0. Let's submit. Great.